Hello. Wow, wasn't expecting quite so much boom out of that microphone. Thanks for joining us today. My name is Fritz Kunstler. I'm a principal consultant in the global financial services practice of AWS ProServe. I've been an AWS customer since 2008, and I joined AWS more than 3 years ago at this point. My job is to help customers build the confidence and technical capability to run their most sensitive workloads on AWS. And toward that end, I have done an awful lot of work in AWS IAM. I'm very lucky to be co-presenting with a customer today, Alan Garver, who I'll be introducing in just a few minutes. As a reminder, this is a 300-level session, so we're going to dive deep on some technical details about identity and access management and automation in AWS. It'll be a lot to process if you're not comfortable with concepts like IAM roles, policies, permission boundaries, SCPs, and the like. Our agenda. First, I'll share some observations regarding financial services customers and how they've dealt with AWS IAM in the past. Next, I'll recap some important and relatively recent, and by recent in this case, I mean like past 12 months or so, IAM-related announcements. Then we'll lay out a strategy that synthesizes the learning from some of our most experienced financial services customers. And finally, we'll wrap up with some technical examples and implementation guidelines. In the past, the all-or-nothing nature of AWS IAM forced centralized administration by financial services security teams. But that's no longer necessary due to new features in AWS. Today, we aim to show you how you can not only achieve your security objectives, but actually strengthen your posture and accelerate your business just by doing these three things. Before I'll resist the urge to redo the slides. Before we dive into the details, though, I just want to take a minute to sort of align expectations here. So, what do we mean by IAM? For our purposes today, we're talking about IAM in terms of the native preventive control mechanisms for AWS APIs. In other words, all the places in AWS where you can apply a JSON policy code to control access to your resources. So that extends beyond just the AWS IAM service itself into things like organizations, KMS key policies, or S3 bucket policies. But access controls for apps that you're running, that you deploy and run on top of AWS, or for network traffic, or for operating systems, or really anything else, are out of scope. So again, to reiterate, we're really talking about access controls for the AWS APIs exclusively today. To prevent any confusion, three quick terminology sort of definitions here. These are things that you'll hear us sort of repeated throughout this session. So if you hear us refer to account, I just want to be clear that we're talking about a standard AWS account and not a IAM user account. So account is always going to be a reference to the AWS account, the container of your resources. When we talk about an organization, another overloaded one, that's the AWS organization, so meaning the entity that you create to consolidate your billing across a bunch of AWS accounts to organize things and apply policy. And by policy, we'll try and be explicit as to whether we're talking about an identity policy or a resource-based policy or an SCP. Regardless, it's going to be something that could be codified in the JSON policy language of the IAM service. So by show of hands, and I can sort of see people only in shadow, but how many people here actually work in financial services firm? Okay, cool. And how many of you are developers? Or how many of you write code as part of your job anyway? All right, great. So one of the privileges of working in professional services in AWS is that I'm often embedded with my customers for extended periods. And while every company is unique, there are also some commonalities that we see across financial services that will probably look pretty familiar to those of you who work in financial services firms. So these are mature, highly sophisticated, centralized security organizations, really obsessed with protecting customer security and privacy, the strong preference for preventive controls, very process-oriented, risk-averse, and they take their work very seriously. Why is that? Well, there is a lot at stake, and I'm not talking about MRAs or fines or profit or even brand image concerns. At least the security people who I work with in global financial services firms, they're actually consumers or customers of these firms too. And they and their families depend on checking accounts and investments and their identities being protected just like you and me and everybody else does. So that's our sort of backdrop and what we had in mind as we set out to sort of develop a strategy for IAM for financial services. Before we could do that, we needed to come up with some sort of objectives, or what are we trying to accomplish with this strategy? And at the top of the list is certainly to free builders to innovate and experiment, to do that quickly, but also safely. I just want to make clear that we think it's really important to not sort of assign this just to the business or to your application or developer teams. As a security team that's responsible for AWS IAM, if you can't do this yourself, if you can't go fast and experiment quickly, then you're actually sort of less secure, because when there is a vulnerability or something comes up, you need to move quickly to close it, then you don't really have the ability to do that, and that can become problematic. So not only for the sake of the business, but also for the sake of security, it's important to be able to experiment, to move fast, and to do it in a safe way. So a couple of previous IAM strategies that we have seen used very commonly. So the first, which I'll refer to as centralized IAM, and this is a name I made up. It's not sort of a formal pattern or anything like that, but the idea here is that this is sort of a fully managed or zero trust approach. It's one of the most common we've seen. And in this scenario, builders are going to tell security what they want, what they need, to do, and some security goes and implements it. So there are some benefits here. One of them is that you develop a competency center inside of your security team, so real expertise starts to develop in AWS IAM in security, and it's hard to sort of overstate the value of that. But the process tends to take a really long time because you've got a whole bunch of application teams and just one security team. And as a result, things move slowly, and you also end up very often in a scenario where builders are requesting more permissions than they actually need because they know how long it's going to take to iterate and to get what they need if they don't ask for it in advance. So this really does not scale as you start to move more and more into the cloud. Second strategy, and visually it sort of looks similar to the first, it also tends to have a close relationship to the existing change control processes that a lot of our customers have. So in this scenario, the builders will actually attempt, or developers will actually attempt to codify the policies they need themselves in advance, but they still need to hand those off to a security team for review and approval and to ultimately be deployed into AWS. Now, there's some advantages to this, and good ones, especially as it relates to accountability, because decisions about access are now being made by the people who are closest to the applications and the data that they're trying to manage. But the process is still slow and it doesn't scale because you have this problem remaining where you've got a ton of application teams who are all relying on one central security team. And on top of that, you end up with sort of scattered proficiency and a situation where more policy defects may actually get through because the competency that you had in the previous strategy, where you've got concentration of technical expertise in a security team, that can be lost. Fortunately, AWS has released a sort of bunch of IAM-related features in the past year or so that used together sort of get us to a place where there's fewer trade-offs. Because as you can see, thinking back to the objectives slide from a few minutes ago, so neither of these strategies really tick all the boxes there. We're not going to have time to talk about all these today. Alan's going to cover several of them later on in the slides, but I do want to encourage you to explore all of these. This is not all of the IAM-related features that we've announced in the past 12 months, but it's some of the ones that I was sort of most excited about and I think deliver the most value when they're used together. So definitely go and take a look at that stuff when you have a chance. As a result of this, the new features or enhancements, we really have begun to see a change in the approach of even our biggest and most conservative financial services customers, and sort of toward delegation, towards automation, towards increased use of detective controls. And I actually should have started here by saying that sort of at enterprise scale, those are really critical things. There is this tendency to think, or I have experienced this anyway with a lot of my customers, is a tendency to think at the start of the journey that the capability you're trying to develop is the one, the capability to grant access, to get people the ability to use the services. And I think that's kind of a common mistake because you're treating then, if you look at it that way, you're treating the automation as sort of an advanced feature or something you can figure out later after you just take care of the access problems. But in reality, for large enterprises, it's actually the automation, the ability to do this at scale, to deliver your preventive control policies, your IAM policies. That's the capability that is critical to develop. So the evolution that we're seeing here, it's really driven by a need to sort of free the business to experiment and innovate faster, but also for security to focus on things that are more valuable to the business than writing JSON policy code, which turns out to be incredibly time-consuming, especially if you're a large enterprise and you have all of these application teams that are really chomping at the bit, or business units that are in a hurry to get onto AWS, and you're sitting in between them and the access they need to do that. So a parting thought before I bring Alan up to describe the new strategy. Least privilege is a journey and not a destination. So what do I mean by that? Well, it's not practical to create at enterprise scale, that is. It's especially not practical to create IAM policies to cover every scenario that as security people we imagine, right? Nor is it practical to try and protect every single resource that's going to be deployed in advance. It just doesn't work. And fortunately, you don't need to do that when responsibility for IAM, for securing your AWS environment, is shared with application teams. To enable that sort of shared responsibility for IAM, as you move left in your SDLC, your policies need to get less restrictive, to enable those sort of experimentation or allow for the experimentation that the application teams need to figure out the permissions required so that they are dealing with the least privilege and setting up these policies themselves. So write policies to prevent the critical things and sort of the broad strokes, then use detective controls and analytics to iterate, continuously sort of rescoping everything towards least privilege. With that, I'd like to introduce Alan Garver.
Thanks, Fritz.
Thank you.
Hey, everybody. My name is Alan Garver. I run a cloud engineering group at AQR Capital Management. We're a quantitative asset management firm based out of Greenwich, Connecticut. My team's working on enabling secure use of AWS services for the engineering groups that are at my firm. So Fritz and I have worked together for a long time, a few customers in common. And so I was excited when he called me up and said, hey, I'd like to talk about this. So we set out a little while ago to sit down and kind of talk about how some of these new features that he just described sort of enabled a model change, a new way of thinking when we think about how we're going to go manage access to IAM and AWS. And so one of the things that Fritz described was this trade-off that we kind of always feel when we're working in financial services. This kind of, either we can let developers move quickly and have the freedom to go and experiment with IAM and implement policy along with the app stacks and the things that they're creating in AWS, or we can be confident that we're not going to have bad policy getting deployed into our operating environments. It was kind of a trade-off. You couldn't really have both. You kind of had to decide. And as most of you know, there's a lot of financial services people in the room, that when you experience this trade-off, the developer always loses, right? We're always risk adverse. We lean towards more preventative controls over developer freedom. And so, but fortunately, AWS has done some interesting things in this space to really help enable us, and they're changing that paradigm. They're making it so we no longer have to worry about those trade-offs, and that's what we're going to spend the rest of the time talking about here as we look at this new method. So before, your IT security groups kind of had to be police officers, traffic cops, if you will, around the things in IAM that were being deployed into AWS. And that was really the best way to kind of assure that some experienced expert was coming in to look at the policy that was going there and making sure we weren't doing things that we shouldn't be doing in our IAM operating environment, granting access, overly permissing resources, and doing things like that. So what I'd like to do is spend the time kind of presenting this new theory, is that these new features that have come out over the last year have really opened up a new way of thinking around this baseline policy that we can implement in AWS that really does free the developer to have full access to go do the things they need to do in AWS with IAM, and they can build the resources, the policies, and the users and the roles that they need to go get the job done for the thing they're trying to implement. And we can do that in a way that puts the proper boundaries and controls in the AWS operating environment so that we're very confident about what's being implemented. We don't have to worry, we don't have the same worries about risk. And so I'm going to do this kind of in three steps here. The first, I'm going to talk about what I mean, what Fritz and I mean about preventative control baseline. So the idea that we're going to create that baseline as a product. So the baseline itself will consist of all the controls and everything that we want to implement in an AWS operating environment, so that we have those boundaries that allow the developers to move freely. Then we're going to explain the concept of using a product team to manage that baseline product. And I'm going to borrow from Amazon's sort of definition of a service product team. Some of you may have seen some of the material. There's lots of material out there where Amazon talks about how they manage services and products. So we'll take a peek at that, just defining what we mean by a product team. And then lastly, we'll leave you with some examples that demonstrate what we're talking about. So, the idea that we'll show you some samples of service control policies and permission boundaries that leverage things like principal tags and things like this that really drive home what you can accomplish in this model. So First, let's talk about what we mean by the security baseline product. So a product is really just a set of capabilities that you would manage an environment that people could use. In the context of AWS, if you're thinking about AWS products that you use every day, you might use EC2. That's an example of a product. And so in this case, we're saying the product we want to create is the security baseline, basically the configuration of a security controls framework in an AWS account. And so there's a bunch of things included in this. The things that would be a part of our product would be things like the OU structure of our AWS Organizations. So AWS Organizations is a service that allows you to organize your AWS accounts in a way that you can apply a policy to those accounts. Policy that you apply to organization OU structures and accounts are known as service control policies. And this is a relatively new feature. Service control policy has been around for a little while, but AWS has recently given us the ability to do really fine-grained permissioning in the service control policies. And that's a pretty powerful feature, and it really is an enabler for this concept of treating the baseline configuration of an account like a product. So another example of something that's in our security baseline product might be the functional user roles of people that are actually doing work in the AWS account. So this would be like your developers that are developing any one of the service products that they're trying to build for the business. These are business-focused or business-specific applications. So you would be creating the functional roles that they would be assuming into the account to do their job as part of this baseline security product. You'd also be putting permission boundaries in that context. So permission boundaries, we're going to talk about them. IAM policies that you can attach as a boundary to IAM entities. So that would be part of the product here. And then some other things that you're probably more used to. Many of you are probably already doing a lot of these things in code or some sort of automation that deploys these things across the fleet of accounts that you manage in your organization. But things like CloudTrail and guard duty and config rules and detective controls and all of those things would kind of be bundled in here. And so we could treat these things like a product and deliver them into the operating environment, just like any service team would deliver their product to their customers. And that's the concept here. What's excluded from our product, and again, the real value of this is that because we don't have to have this trade-off anymore between developer freedom in IAM and the ability to put preventative controls in place, we kind of have detached those two entities into separate things. We now have developers are free to go and create their own IAM policy and roles and users and use them in a way that's specific to their application. And so the thing we don't need to include in our baseline product would be those roles, those user policies that are going to be applied to the specific use cases of those teams. And then any of the other resources that they would need to go build the services and capabilities that they're doing. So we've kind of now introduced these two roles. The idea of the old traffic cop that used to stand in the way of all the merges that were coming in terms of IAM policy, now actually being a service owner and building an automated service that's delivered just like any other service, but they're responsible for the security baseline product, represented as a police uniform. And then in the lab coat, I guess it's a lab coat, is the idea of another service developer, consumer of that baseline security process. So these two roles now we've transformed the way we think about separation of duties in this model. So this concept of being able to put boundaries around what a developer can do with policy, with IAM policy, users and roles in AWS, means that we can have a full sort of isolation between the two functions that they're performing. So the security baseline product that we're talking about is something that gets delivered into the AWS account, and it sort of defines the boundary of what's possible. It sets the limits of what somebody can create in terms of IAM in an account. And then we have maybe lots of development teams that are trying to implement different services for different reasons. I've randomly named a set of fake services here. But the idea is that what they're building, what these teams are building in AWS is a set of business-specific applications. But those business-specific applications do need IAM entities to get their job done. So imagine you have an EC2 instance that needs an instance profile in order to be able to talk to an S3 bucket, or you have to give that EC2 instance permission to go talk to other resources in AWS, and so therefore you need to be able to create an IAM policy that you can assign as a role on that instance. And so these developers are all creating IAM objects. They need to create IAM objects to build the services and the capabilities that they're doing. And they need to actually build them specific to purpose so that they can implement least privilege. We wouldn't want to give an EC2 instance, allow all to all resources just because it needs to talk to an S3 bucket, for example. So we can, in this model now, give them the freedom to create those things and know that they can't go outside the boundaries that we've defined for them from the security baseline. Taking one more look at this isn't really a proper Venn diagram of where service control policy and permission boundaries sort of meet with instance roles or identity roles. But the idea here is sort of elaborated at a different view. We have our IT security team sort of managing the boundaries that are in the AWS operating environment, and then our developers have the freedom to go and create Lambda execution roles or service catalog product roles or CloudFormation delivery roles, whatever it is they need to create specifically for the services they're trying to build. And so they have the freedom to do that. They can make the API calls and those things can be created. And so we're confident though, and we're gonna elaborate a little bit further on service control policies and permission boundaries, but we're confident in this model that a developer cannot exceed the permissions, the boundaries that we've laid for them. So if a developer tries to implement something that's gonna mess with the CloudTrail config, or if they're going to implement a policy that allows, administrative type policy that allows resource star, the effective permissions on those policies would exceed the boundary that we've created for them, and therefore the effective permission they would get permission denied trying to do things that are outside the boundary. So this really this changes the model dramatically. It means that we can really have confidence about delegating that access out. So that's what we mean about the baseline product. It's kind of the security controls that get deployed into an environment. What happens in this model is we've now removed the traffic cop from the scenarios that Fritz shared earlier. We're no longer a bottleneck as security specialists in the path of all of our developers trying to deploy things into AWS, but we kind of have a new problem now. Not really a problem, but the dynamic of where we need to be fast and be able to move quickly has altered a little bit. If we're delivering this security baseline into AWS, inevitably we're going to define a boundary that some developers are going to have to challenge from time to time, right? And in the beginning, when you first implement boundaries of any type, you're likely to miss the mark in some way, and so developers are going to be coming to you a lot saying, hey, I need permission to do this, or your boundary is too restrictive here. And so you're going to be sort of inundated with feature requests. And so in this model where we're going to be delivering that policy as a product, we really need to act like a product team. We need to be agile. We need to be able to move quickly. We need to be able to anticipate or see the changes that are feature requests from the developers that are trying to get the job done, and go and implement those features, test them, make sure they're good to go, and ship them out to the live environment as quickly as we can. And one of the best ways to do this is to behave, as Amazon would define, like a product team, a service team. And so let's spend a minute here talking about what we mean. What is a product team? What is a service team? Amazon thinks of service teams kind of as two pizza teams. You may have heard that term before. A two pizza team really just, in Amazon speak, means a team that is not larger than you can feed with two pizzas. The idea was to focus on keeping the team small and giving them full ownership of the things that they're managing. And so it's not really always true. I mean, depending on who's on your team, by the way. Two pizzas might not be enough anyway. But the teams are vary in size, but the whole idea is that you want the team to be small because you want to give them full ownership of the product or the service that they're managing. When they're trying to evaluate features, they want to be able to make decisions quickly. You don't want a lot of bureaucracy. They don't want to have to go out and talk to different entities. You want them to have full ownership of that product. And so to operate efficiently, the team needs to be small. The larger it is, the harder it is for them to move quickly. And so that's the idea of the two-pizza team. By giving full ownership to these product teams, you've heard Werner say before, it's not just ownership that we're talking about here, it's also accountability. The term that he always uses is you build it, you run it, and that's effectively how they operate as service teams. If any of you have done anything extensive on AWS and you've encountered a problem with a service like the containers to the ECS container service, or maybe EC2, or you've had a Lambda problem and you've had to open a support ticket to AWS, it's not uncommon for your issue to be raised directly to the service team who's developing the APIs and the things that are associated to that product. And so by aligning this like accountability to the customers with the ownership of the product, they've kind of created this you're not able to really blame anybody, but you've connected those services directly to their customers, and you tend to be far more efficient at delivering what your customers need. And so the product team is more than just sort of this entity that's small and can make decisions and own and move fast. They're also fully autonomous. So many of you know that Amazon has a bunch of features. AWS has a bunch of features like pipelines and code commit and things like this, tools that help them be fully autonomous when they're developing and delivering their services. So I'm going to spend just a minute here. I know it's a security talk, and now I'm getting into DevOps land. But what do we mean by autonomous? It means that everything that we're implementing that as code. So literally everything is implemented as code. So when we talk about the service control policy and the permission boundaries and the functional user roles and CloudTrail config and all of those things, in the context of a security baseline product, we would be implementing all of those things in some form of code and delivering them out to our AWS and operating environment through an automated means. We resist the urge to go into the AWS console and make changes because those changes are not repeatable, they're not testable, and they're difficult to manage, especially when you have a scale, many accounts that you have to manage. And so by codifying all of those resources, we get the ability to implement them in a controlled environment and test them and make sure that they work. We can use things like a delivery pipeline to automate the deployment of them into some CI environment, run a bunch of tests against that CI environment, and then immediately release it to all of our customers. So an important distinction here about writing automation and delivering things through automation to an AWS operating environment is it's not just enough to just write a bunch of code. Like even if you're writing CloudFormation or a bunch of protocols out to the AWS APIs to define your resources, it's not enough to just do those things. If you're not careful in the way that you organize these things, and so Amazon product teams tend to be focused on this, and basically the idea is a unit of deployment. Think carefully about operating in units of deployment. We're going to elaborate on this a little bit more. But the idea is if you were to take your entire landscape of AWS accounts and write a single script that was trying to manage all of your AWS accounts, say you have 10 or 20 or 100 of them, every time you want to make a change, your automation is touching every single one of those accounts. And that's generally, it introduces risk into your deployment process. So what you really want to do is you want to focus that automation on a single unit, somehow focus on a unit of deployment, and then repeat the process across all the accounts that you have to do. And so that's the idea here, is that it's not enough just to rely on these pipeline tools and do things in code. It's also important to stop and consider how you're going to implement units. Consider for a minute somebody that's a developer on our IT baseline, security baseline product. She's been given a feature to work on. She has to go write the code associated to that. Maybe it's something in the service control policy or something in a permission boundary. She needs a place to go and experiment with that feature. She needs somewhere from her local development box to be able to have a direct access to an AWS operating environment so that she can make direct API calls, or maybe write a CloudFormation template and call create stack directly to those accounts so that she can develop the feature, make sure it works, test it locally on her workstation, and all of that has to be done before she even commits the code to her source code repository. And it's really important that she has a unit of deployment to work on when she's trying to implement these features, so that she can reliably or confidently know that the things she's deploying will apply successfully across the fleet of accounts that eventually have real customer data in them. So in the example I'm giving here, I'm calling these AWS accounts, or this organizational OU, this one unit of our OU, a sandbox. So in this case, she'll write the code. Maybe it's CloudFormation. She'll test it. She'll write some functional behavioral tests against that environment. She'll make sure it works. Maybe she'll do some linting and various things. And then finally, she's ready to make a commit against the repository that eventually is going to trigger the pipeline. So what that looks like, it's different for different teams. A lot of financial services organizations that I've worked with, including my own, we have a peer review process. So we don't tend to commit directly to the repositories that trigger our build pipelines. We go for peer reviews, right? So you'll have a couple of people come and look at those pull requests. They'll kind of evaluate them. Maybe they get kicked back and forth. She has to make a few changes to her pull requests, and eventually we all agree on what that feature looks like, and we all think it's a good move, and we merge that that code change, and now a pipeline wakes up and actually automates the testing and deployment of that change. And so in the case of a unit of deployment, we have now another unit. In this case, I'm calling it the CI unit, or the continuous integration unit. And this is a set of AWS accounts configured in the same way that our sandbox unit is configured. And our pipeline is the only thing that is managing and implementing in those accounts. It's free of manual intervention, and so we could be confident that the things that are coming out of the pipeline in this space will be reliably implemented and tested, and in a way that we're confident, so that when it comes time to deploy those things out to the real environments where our customers are and where our real data is, we have a high sense of confidence that it's going to apply there safely. And so this is the idea. And then all the way out to the end of the pipeline here, you can see we're actually deploying out to whatever the number of accounts we have are. If you've successfully implemented this idea of a unit of deployment, you can take a single code base and run it once, or you can run it 1,000 times, and you end up with 1,000 copies of whatever it is that you're implementing. And that's really the idea here, is it's repeatable, it's testable, it's isolated so we can work on it in a development environment. It's kind of an important feature. And it applies here to when we're talking about the baseline products. I just want to pause here for a minute. I don't want to give any impression that we're recommending any kind of organizational structure for your organization. Just kind of made up this line of business. It's important for you to consider when you're working in AWS Organizations. It's sort of tightly coupled with the security baseline product that we're talking about here. When you're implementing service control policies, it's very specific to how your organizational OU structure is built. So it's key to spend some time before you get started reflecting on that. Your organizational structure in AWS Organizations should really accurately reflect how your organization operates, the reality of what your organization looks like. And it's probably going to be unique for all of you. It may not be the same between two, but it should adequately reflect the way it is. So take our examples here as a grain of salt. So hopefully we've explained a little bit about what a security baseline product is. We've explained a little bit why it's important to implement good CI/CD and product management over that so that we can iterate quickly and be repeatable and testable. We'd like to share with you now a few examples of some of the new features that have come out and talk about how it applies to this model. So we're going to go through, first of all, I'm going to introduce the 4 entities. We'll talk a little bit about it. Fritz earlier mentioned that we would go into these a little bit further. Service control policies I'll start with. These are all IAM policies, so they're just, it's a JSON declarative IAM language. And it generally looks the same, and the policies all have the same components to them, but they all have different purposes. And so we'll talk first about service control policies. Service control policies don't actually grant any permission. They just set the maximum level of permissions that can be associated to an identity in an AWS account. That's really the purpose of the service control policy. So you write an IAM policy document, you associate it to an OU in your organization, and now effectively all of the accounts that are in that OU are bound by, they have the maximum permissions of whatever the policy says in your service control policy. So you can do all kinds of interesting things here. You can turn off regions, you can turn off AWS services, you can specifically identify resources in the accounts that are in that OU and declare who specifically can access them. And because this is declared all the way at the top level, it's really sort of stamped over the AWS account. It kind of controls the maximum permissions that are possible in that account. Doesn't matter what permissions you give to any resource in the account, it cannot exceed the maximum permissions that are declared by the service control policy. So very powerful. What's new here, this is a little older, this service, than the last year, but what's new about service control policies is recently AWS has released the ability to do fine-grained permissioning. This means we can now introduce things like conditions and various other properties into the service control policy, and this really lets us get fine-grained with some specific things in the service control policy. So we're going to give you a couple of examples of things that we can do in the service control policy. Next is the permissions boundary. Permissions boundary is just an IAM policy. It's just like an identity policy that you would define in any of your AWS accounts. It shows up like a managed policy, but a permission boundary is very much like a service control policy in that it just sets the maximum permissions that a thing can have. And so it doesn't actually grant permissions, just like the service control policy doesn't grant permissions. But this is effectively a service control policy that you can apply to an IAM identity. The one difference between these two is that a service control policy has sort of control over resource-based policies. We're going to talk about those in a second. And a permissions boundary does not. A permissions boundary only has the ability to limit identities. These are through users and roles, not resources. So permissions boundaries don't get applied to the account. They get applied to IAM identities. And so we'll talk about that too. Next is the identity-based policy. These are the ones that you know and love and interact with all the time. Just normal policy that does grant permission. The identity-based policy is just an IAM policy. You can either be managed or can be attached to a user or a role or a group. And these policies are the thing that give permissions to a thing. Typically, you can't do anything in AWS without some sort of identity-based policy. You can do things like make resources public and things like that, but generally you need an identity-based policy to do something. And then last, we're not going to spend a lot of time sharing examples of this, was this idea of resource-based policies. These are things like policy that gets applied to a KMS CMK, or a bucket policy that gets applied to an S3 bucket. These are policies that get attached to specific resources and can influence which principals are allowed to interact with that resource. Think of it as an IAM policy that wraps specifically around a resource and not an identity. So we won't go too deep into it. There is some interesting things when you're looking at permissions boundaries as it relates to resource-based policies. So the documentation here is pretty thorough. If you go out to the AWS documentation site and you look for permissions boundaries, there's lots of really interesting examples of and service control policies, of using resource-based policies and identity-based policies in combination with things. So the big picture here, when we look at these things put together in an AWS account, and our security baseline product now has kind of deployed a collection of these things into our AWS operating environment. When we look at sort of all the different types of policies put together, we kind of sense the picture of what's happening. So imagine a principal that somebody has created an IAM role for, an IAM-based, identity-based policy for, and that principal is trying to do something in AWS. And we have attached a permission boundary to the role, and we've also got the organizational service control policy applied. The effective permissions of that principal is basically the subset of all of those policies put together. So it can't exceed the boundaries of that little box in the middle. And so we're limiting what the effective permissions of that resource is based on sort of the subset of those policies. And so when we put this in the context of our security baseline product, there's a couple of things that it's important for us to consider in the onset. And so I'm going to share with you now some examples of implementation of these things. And there's kind of 4 things that we want to look at as we're determining how we're going to go implement service control policies, permissions boundaries, and identity-based policies in our AWS accounts. First is we need to protect the baseline resources. So this idea of implementing a baseline security product is we're going to write a bunch of automation that's probably going to do things like spin up CloudFormation stacks, create IAM roles, create permissions boundaries, create service control policies. It's going to set up CrowdTrail. It's going to do all these things. For all of those things that our baseline product is creating, we need to go into the boundaries that we're defining and protect those resources. And that's really the first mission here is we should be able to establish the baseline control and make sure that it's off limits to everybody. So that's kind of the primary function of our baseline product. The second function is to determine what's off limits in an account. We already talked about how we can switch things off, like turning off regions and turning off services. So we should take a holistic view of what the use cases are in the account. If we don't need game lift or lumberyard, for example, we can kind of switch those things off in the service control policy. So we can determine a bunch of things that might be off limits. Next is use tags. So there's a couple of new announcements. There's things like principal tags, which is a new feature that AWS just came out with that allows us to tag principals and use those in conditions and IAM policies. We'll show you a brief example of that. And then most resources have the ability to be tagged. You also have some entities that take a path. So when you set these paths and these tags, these can be useful when you're defining conditions in any policy, whether it's an identity-based policy, but certainly in the context of a service control policy. For example, we can say, hey, this is we can tag a resource as part of the security baseline product, and then mark it off limits in the organizational service control policy. And then we're confident that nobody can alter it. So let's take a look at examples of these. The first example I want to walk through is, let's pretend that our baseline security product for a minute is a CloudFormation template. So for those of you that have used CloudFormation before, this is like a bash example of calling the AWS CLI to turn a CloudFormation stack into a CloudFormation template into a CloudFormation stack on AWS. So CloudFormation is a service that allows you to declare resources in AWS, either in JSON or YAML format. You can say, I want an EC2 instance in this availability zone with this security group, and et cetera, or you can say, I need an IAM policy. It's a permission boundary, and I want it to have this policy document. And so you can define these things in CloudFormation, and then you can call the create stack call to the AWS API, and it will take that template and turn it into actual running resources in AWS. And so in this particular example, we're using, this might be in your Jenkins pipeline. You might not be using the AWS CLI, maybe you're using Boto or the Java SDK or some other SDK to actually create the stack for your CloudFormation. But this simple example is bash. And in this case, you'll notice that last line, and this is a somewhat newer feature for CloudFormation. We can now tag CloudFormation stacks. And so this in and of itself doesn't really do anything. We're tagging this specific stack. It's named our baseline IAM stack, and we're tagging it with an app ID called security baseline. Again, it doesn't really do anything until we look at the larger context of what we can do with that. Let's go to the service control policy now. We know that we've just launched a CloudFormation stack. It's got some important stuff in it. We don't want people to be able to mess with it. So let's go to the service control policy and say everything in the OU, unless, so I'm going to read the policy to you. It's kind of hard to follow policy documents, and just want to be clear, these aren't actual policy documents. They're just snippets of potential statements that you might see in a policy document to demonstrate the examples. But when you look at this specific statement that might show up in your SCP, in your service control policy, in this particular case, we're saying for any CloudFormation stack that is tagged with app ID, and the value of that tag is security baseline, and the principal that's trying to act on that stack is not our role security pipeline, then deny, delete, update, and execute. So by implementing this policy in the service control policy, this effectively puts a control around that one specific CloudFormation template that we've maybe deployed into a bunch of accounts in the OU, and it said only this one role can touch anything that's tagged with security baseline. So pretty powerful feature. You can now kind of switch off complete organization control to very specific resources. And this is something that Amazon just released not too long ago, the ability to do these fine-grained conditions in your service control policy. So that's one example of how the baseline product that we end up deploying could implement a control. We're protecting our own resources. Let's talk a little bit about using tags. So again, here's another statement that could show up in either a permissions boundary or a service control policy. And in the context here, what we want to do is we want to say, we're going to use something called principal tags. And principal tags are a new feature that AWS recently released. This allows us to tag principals. And so now we can write conditions in policies like the service control policy, and we can say, hey, we're going to look at the tags that are on the principal that's trying to act on a resource in AWS, and we can make sure that it's tagged with app ID, and that the value of that tag has the same value as the app ID of the resource it's trying to interact with. Pretty cool stuff. And if you implement this in your service control policy, again, it's like a rigid control that says people can only manage things that are tagged the same as they are. So we can use this for all kinds of use cases. We can protect resources with this. We can let a team create a resource that only they can interact with and no other teams can. All kinds of interesting use cases here, and lots of examples out on the documentation. So that's an example of using tags and how that can be very effective in the control policies. Next, let's take a look at enforcing the creation of tags. And again, this is a very abridged version. There's probably more to your service control policy than just this. But for the purpose of showing the example, what we're going to put, let's say we put this in the service control policy, we're going to say, hey, look, anybody can create a role as long as the role they create has a tag called app ID. We could go further and declare things like making sure the tag has appropriate values on it, things like this. But in this particular case, it's not possible to create a role in this AWS account unless we tag it. So again, pretty cool stuff. It's important to use tags because, again, we want to do fine-grained permissioning in the service control policy, and so we really want things to be tagged so that we can do that effectively. And then the last thing I'm going to talk about, and this is really where we get into the enforcement. We didn't talk much about permissions boundaries and how that enforces, how that really opens up the ability to delegate. But at a high level, what a permission boundary allows you to do is that you can give somebody the ability to create roles or create users as long as they attach a very specific boundary to that IAM entity. And so this specific permissions boundary technique basically says, hey, look, you developer, I'm going to let you create whatever IAM entity you want. You get to create role. You can attach policies to the role. You can create a user. I can give you all those permissions, but oh, by the way, you must attach this one very specific permission boundary. And when they do that, again, that's setting the boundary of what their role is allowed to do. So even if the identity-based policy that they give to that role that they've just created is allow everything, the boundary is still going to say, nope, you can only have this. And so that boundary that we end up deploying, that policy we end up deploying, we would again have to protect that in the policy. We'd have to make sure that nobody's allowed to alter that policy, but it gets deployed by our security baseline product. And this is really where the separation of duties comes into play. Because we can implement that policy, we can control the maximum permissions that anybody's allowed to create a role to be able to do in the AWS account. So we can be much more confident about giving the developers the access to create their own IAM policy. So now they can create things like Lambda execution roles and EC2 instance profiles, and they can build those things to the purpose of what it is they're trying to build. They can write a very specific, least privileged, fine-grained policy that just lets it talk to a specific bucket or just lets it write to with a specific CMK. So those are the examples. We thought we'd finish with a little bit of maybe advice, implementation guidance, things that we've seen along the way as it associates to some of these things. So again, hopefully it convinced you that it's now possible to really effectively delegate access to the developers that are trying to do business-based things in your AWS accounts because of service control policies and some of the new features that are coming out. If you build a service well, you can actually deliver that as a product just like any other product team, just like the EC2 service team or anybody else. But there's a couple of things that we'd suggest if you're going to go do this. First of all, everything is in version control. Important that we use version control. Version control gives us the ability to track histories of code changes. We can see specifically who's doing it. We can control and gate the access to the master branch, which would cause things to be actually deployed into our environment through pull requests and things like this. So source version control is very powerful. Do everything in code, basically. Use tags and paths on your resources so that you can effectively condition things in your boundaries. Don't hide the boundaries. This is something maybe we've seen people do where there's this urge to say, oh, this policy boundary, it's sensitive because it really is controlling what people have access to, so we shouldn't let anybody see it. So you kind of build your policy to block access to it. Imagine the frustration that a developer feels when he can't tell what's blocking him, right? So there's really no need to hide it. It's good to be open with the policy. Certainly protect it. Don't allow anybody to change it. But allow them to see it, because what most good developers will do, why am I getting permission denied on this thing that I'm trying to do? They'll go investigate and figure out what it is, and they'll bring to you the proposed, oh, I need this permission that you're denying me. And it'll make your job a lot easier in implementing those features and having happy developers. So don't hide the boundaries, let people see them. Describe your intent. It's important to put somewhere the intent of a policy so that when a developer is trying to understand what's going on, they can understand the intent, and they can maybe map their suggestion based on what you're specifically trying to accomplish. And then the last couple, detective controls, we talked a little bit about it earlier. None of these policies and permissions boundaries and new capabilities really eliminate the need to have detective controls. We still need all those things because nothing really changes here. Developers can implement bad policy. There's nothing preventing them from doing it. They just can't have an identity that's allowed to assume permissions that it otherwise shouldn't be allowed to. So bad policy can still get out there, and you should still look for bad policy and tell developers that they need to make things least privilege. Nobody should be building allow star to everything just because the permission boundary is going to protect the overall resources. So detective controls are important. You should be still looking for and gating and writing config rules that are looking for bad things in the accounts and alerting on those. Just having these permission boundaries doesn't relax that requirement. But you should also feel like you don't have to solve all the problems up front. You can be iterative. And so if you have detective controls today, these can help you feel more confident about sort of opening the gates here and implementing the boundaries. And then last, the tools here, pipelines and code and all those cool things. They don't just mean that's all you have to do. Your security is really only as strong as the controls that you have around the automation that you have. So don't just go get Jenkins off the internet and deploy it in your account and forget about it. Do good things about patch management and access management and all those things. It's really important. Your tools now in this model have become very important to protect and be sure that there's no risk to things there. So pretty much the end of the talk. We told you at the beginning one of the things we were going to tell you. Here we'll kind of review. Hopefully we convinced you that now more than ever you can confidently delegate access to IAM. And so to your builders or app owners and people in the accounts, because of the ability to create boundaries and to protect the limits of what people can do. It's really important, though, if you're going to go implement these things and you have a larger organization, to treat them as a product, meaning put good automation practices around them, build a service team for this product, and treat it like a service, automation, testing, and all the good stuff. And then lastly, use all the fine-grained features that AWS has provided you to really strengthen and tighten the separation of duties. And what you'll see is, what we know you'll see is that in these environments, your developers will actually implement least privilege better than you've ever seen. So that's it. Some other talks that you might be interested in. A few things tomorrow that go deeper on the topics. Some stuff on permissions boundaries that go super deep in them. There's a DevSecOps masterclass that can talk a little bit about some of the concepts of pipelines and things that we talked about today. So recommend that you check out some of these sessions. And on behalf of Fritz, we thank you very much for taking the time. We know it's late. It's beer o'clock here on a Tuesday. So I appreciate you coming, and thank you. We're going to hang out for questions, so if anybody wants to ask questions later, we'll be outside. Thanks, everybody.